The 2026 USS Zumwalt DDG-1000 Destroyer remains one of the most technologically ambitious surface warships ever built, and even after more than a decade of service and modifications, it continues to feel like a ship pulled from the future. Belonging to the Zumwalt-class destroyer program, it was originally designed as a next-generation land attack destroyer capable of operating close to hostile shorelines while staying extremely difficult to detect. Over time, however, its role has evolved significantly, turning it into a multi-mission stealth platform and a testbed for emerging naval technologies such as hypersonic weapons, advanced automation, and integrated electric propulsion systems. At first glance, the Zumwalt does not look like any traditional warship. Its most defining feature is its stealth-optimized hull, which uses a tumble-home design where the hull slopes inward rather than outward. This unusual shape dramatically reduces radar reflections by deflecting electromagnetic waves away from their source rather than bouncing them back. Combined with smooth surfaces, hidden sensors, and enclosed weapon systems, the ship's radar cross-section is reduced to a level comparable to much smaller vessels. To enemy radar operators, the Zumwalt can appear more like a fishing boat or patrol craft rather than a 15,000-ton destroyer. This stealth capability is not just about avoiding detection, it is about controlling the terms of engagement, allowing the ship to strike first or operate undetected in contested waters. The ship's physical structure is also highly unconventional. Instead of traditional exposed decks filled with weapon mounts and radar towers, the Zumwalt features a fully enclosed composite deckhouse. This superstructure is built using advanced radar-absorbent materials and angular geometry designed to scatter incoming signals. Even the masts and antennas are hidden inside enclosed panels, contributing to its clean, futuristic silhouette. The result is a ship that looks more like a stealth aircraft carrier than a destroyer, emphasizing concealment over intimidation. One of the most advanced systems on board is its Integrated Power System, IPS, which fundamentally changes how naval ships generate and use energy. Instead of separate mechanical propulsion lines, the Zumwalt uses a fully electric architecture powered by two Rolls-Royce MT-30 gas turbines and additional diesel generators. These systems produce around 78 megawatts of electrical power, which is distributed across propulsion motors, ship systems, sensors, and future weapons. The advantage of this setup is flexibility. Power can be redirected instantly depending on operational needs. For example, during high-speed maneuvers, more energy can be directed to propulsion, while during combat scenarios, power can be shifted to advanced radar or future-directed energy weapons. This design also significantly reduces acoustic noise, making the ship harder to detect underwater by submarines. Propulsion is handled by two advanced electric drive motors connected to fixed propellers, allowing the ship to reach speeds of over 30 knots. While not the fastest destroyer in the world, the Zumwalt prioritizes stealth, endurance, and electrical capacity over raw speed. The quietness of its propulsion system is particularly important in anti-submarine warfare scenarios, where even small acoustic signatures can reveal a ship's position. Originally, the Zumwalt was designed around its Advanced Gun System, AGS, a pair of 155mm naval guns intended for long-range precision strikes against land targets. These guns were meant to fire the Long-Range Land Attack Projectile LRLAP, a specialized guided shell capable of reaching targets over 100 miles away with extreme accuracy. However, due to the extremely high cost of each projectile, the ammunition program was cancelled, leaving the AGS largely without its intended purpose. This became one of the most controversial aspects of the entire Zumwalt program, as a key feature of the ship became practically unusable in its original role. In response to changing military needs, the ship has been reconfigured in 2026 to support modern missile systems instead of relying on naval artillery. One of the most important upgrades is its adaptation for the Conventional Prompt Strike (CPS) program, which is designed to deploy hypersonic missiles capable of traveling at speeds exceeding Mach 5. These weapons dramatically reduce enemy reaction time and give the Zumwalt a powerful strategic strike capability. This shift effectively transforms the ship from a gun-based destroyer into a stealth missile platform capable of long-range precision strikes across continents. Alongside its missile systems, the Zumwalt uses the Mk-57 Peripheral Vertical Launch System (PVLS), which distributes missile cells around the edges of the ship rather than concentrating them in a central block. This design improves survivability by isolating potential explosions and reducing the risk of catastrophic damage if a section is hit. The system can carry a mix of missile types, including anti-air, anti-ship, and land attack weapons, making the ship highly flexible in combat situations. The sensor suite onboard is equally advanced. The ship was originally equipped with the SPY-3 multi-function radar system, designed for high-resolution tracking of air and surface threats in coastal environments. Unlike older destroyers that rely on multiple separate radar systems, the Zumwalt integrates detection, tracking, and fire control into a unified system. This allows for faster decision-making and improved accuracy in targeting. Over time, upgrades have been made to improve compatibility with the Navy's broader Aegis combat network, ensuring the ship can operate seamlessly alongside other destroyers, cruisers, and aircraft in coordinated fleet operations. Automation is another defining feature of the Zumwalt. Despite its massive size, the ship operates with a relatively small crew of around 140 to 175 sailors. This reduction is made possible by extensive automation in engineering, navigation, and damage control systems. Many routine tasks that would normally require large teams are now handled by computerized systems, reducing manpower requirements and operational costs. The ship's internal layout is also designed for efficiency, with improved habitability compared to older warships. Crew quarters are quieter, more spacious, and better equipped, reflecting a shift toward long-duration deployments with improved living conditions. However, this high level of automation also introduces new challenges. The ship is heavily dependent on software systems, which means cybersecurity and system reliability are critical concerns. A malfunction or cyber intrusion could potentially affect multiple systems at once, requiring robust defensive measures and constant updates. The Navy has invested heavily in securing these systems, but the risk remains an inherent part of operating such a digitally integrated warship. The Zumwalt's mission profile has also evolved significantly since its original conception. It was initially designed for littoral or near-shore operations, where stealth and precision strike capabilities would allow it to support land operations in heavily defended coastal regions. However, as military priorities shifted, its role expanded into broader naval warfare strategies, including long-range strike missions and participation in distributed maritime operations. In this concept, multiple smaller and more dispersed naval units operate together across vast ocean areas, sharing sensor data and coordinating attacks in real time. The Zumwalt, with its advanced sensors and communications systems, is well suited to act as a command node or high-value strike platform within such a network. One of the most important aspects of the ship's design is its future upgrade potential. Unlike many older vessels that are limited by fixed architecture, the Zumwalt was built with significant electrical and physical capacity reserved for future technologies. This includes the possibility of installing directed energy weapons such as high-energy lasers for missile defense or drone interception. Its large power reserve makes it an ideal candidate for energy-intensive systems that may become standard in future naval warfare. Despite its advanced capabilities, the Zumwalt program has often been criticized for its cost and reduced fleet size. Originally planned as a class of 32 ships, the program was reduced to just 3 vessels due to budget constraints and shifting defense priorities. Each ship cost several $billion, making it one of the most expensive destroyer programs in history. Critics argue that the cancellation of its original ammunition system and reduction in fleet size limited its effectiveness.